What's up guys, welcome back to the channel and I have a special video for you. Will from the DevOps for Developers channel is going to be taking over and telling you top 7 tips on how you can be a pro at DevOps. So if you enjoy the video, make sure to drop it a like, comment and subscribe, and of course make sure you check out Will's channel, which will be in the description. So go ahead Will, take it away.
Hey, what's going on? I'm Will from DevOps for Developers, and in this video, I'm going to give you 7 tips using DevOps practices that make your application and overall experience as a software engineer better. Tip number 1, keep your code in a repository, whether that's GitHub or Atlassian Bitbucket or whatever. Keep it in some kind of a repo, and this may seem really obvious to you, but I want to point it out anyway because it's not obvious to everyone that your code needs to live in a repo so that you can get all of those features and advantages of tracking your code over time and reviewing changes before they're merged into your main branch. And also, if you work with a third-party provider or you outsource some of your development work, you need this code to be in a repo that you own, because I've seen scenarios where relationships fall apart and then you're unable to move forward with your business or your application because you're spending all of this time, energy, and money negotiating the hostage release of your code. So it needs to be in a repo, and it needs to be in a repo that you own. Tip number 2, automate your development onboarding experience. If you've been writing code for any length of time, I'm sure you've encountered a scenario where you went to a new job or started working on a new project, and just to get started writing code, to get it working locally on your laptop, you had this huge setup process. You needed to install a specific version of Java and install Apache and PHP and MySQL and Redis, and we customized some stuff in Apache, so you got to make these changes to that, and you need some data so that it actually runs and you can execute it locally. So let me go find some kind of a database backup from staging, hopefully, production, if all else fails, that we can give to you and you can install that on your laptop. Let's do away with all of that, right? One of my favorite ways to address this is with Docker Compose and Make files. And these are really small files that you can store in the repository with the code itself. So whenever you bring on a new developer or you add someone to your team, all you need to do is give them access to your code repo, and they can type a single command like make up, and it brings the whole thing to life. Now, one of the other benefits to this is making sure that everyone's running the same version of things. Like if you're using Node.js and you're working on Node.js 14, you specify that in your Docker image, and then anyone else working on it brings it up the same way, so you know that they're getting Node 14 as well. And then when you're ready to migrate from Node 14 to Node 16, you do so in that Docker file. You open up a pull request, it goes through the review process, it goes through the tests, the linting, all of that kind of stuff. And then when everyone else pulls the latest from main, boom, they're up on Node 16 as well. Tip number 3, you need some place for your application to live. And again, this is another one that seems like duh, but the things I want to point out here is choosing the right place. You know, there's tons of options to execute and run your code. You can use Heroku or DigitalOcean or AWS or Azure or GCP or hundreds of other providers as well. So which one's right for you? And for me, the right answer is based on the needs of your team and the skills that you have available. So by that, I mean, if you don't have people on your team with a stronger sysadmin networking style background, I would steer away from things like Kubernetes or AWS or GCP, anything that's going to require you to set up and maintain that infrastructure on your own. I would lean instead towards something that's more like a platform as a service provider like DigitalOcean or Heroku or serverless or any of those type guys. The other thing you want to consider here is how much is your application going to scale? You know, if you're building a new application, you're going to have a low number of users at first, and hopefully it's going to grow over time. but deal with the problem that you have now. So if you've got just a few users and just starting out, save yourself that time and setup work that you have to do with someone like AWS and go with someone like Heroku instead, so you can just get your app live and you can start getting that feedback from your customers, and you can always migrate to someone else over time, especially if you followed tip number 2 and you're running everything in Docker containers. It's not going to make that transition process easy, but it's going to make it easier and achievable. While we're on this step, you also want to automate the process of getting the code out to that service. I'm really against doing deploys from my laptop or my desktop, and against anyone else doing that as well. The main reason for that is because when you leave humans in the mix, it leaves room for error. Imagine a scenario where I deploy from my laptop and I jump on a plane because I'm going on vacation and it's an international flight and I'm completely unavailable for the next 8 to 10 hours, but that deploy went wrong. Now, hopefully I told someone I was going to do that deploy, but we can't really count on that being the case, right? So that's the reason I like to automate the deployment process. It works through your CI/CD workflow, and then anything that needs to happen along with that can be scripted. And since it's scripted, you know it's going to happen every time. I don't have to rely on someone to remember to take a step like telling the rest of the team that they just did a deploy. We can automate that. We can rely on Git hooks and send out notifications through email, Slack, Microsoft Teams, Discord, whatever tools we use for communicating. This has one other benefit to it as well, in the fact that we can restrict who has access to our production servers. This is not a trust thing. This is a best practices thing, so that we can minimize the security footprint by reducing the number of people who have access, and reduce the possibility that errors can be introduced without having a tracking mechanism to see what changes were made. All right, tip number 4. In the last step, we just minimized the number of people who have access to production. So in this step, we want to step up our logging game. We're going to be making logs in our application, but we've got to get them out of that container or out of that server, someplace where everyone else on the team can see them for troubleshooting purposes. Now we also have like 7 different log levels that we can use. You can do info level, warning, critical, debug, error, all these different levels. So take advantage of those and write more log statements than you think you're going to need in your code, and then set the log level through an environment variable on your application. So we can run our logs on info level on a regular day-to-day basis, but in those rare circumstances when we need additional logs to troubleshoot or see what's going on, we can change that environment variable to something like critical, and then restart the application, and we'll start logging out at that new level without having to make a change to our code, do a deploy, or go in and manually change something on the servers. Tip number 5, monitoring. Like, you just got to monitor stuff. Like the obvious things like CPU and memory. I think everyone understands that you have to monitor those. But you also need to be monitoring things that you may not expect, like disk space. I've seen countless numbers of outages because servers ran out of disk space, so it's something you got to keep an eye on. And then you want to have monitoring inside your application as well, because those are the metrics that are really most valuable whenever you're troubleshooting scale and performance issues. So there's all kinds of tools you can use to do this. You can go from a roll your own method using something like a library that plugs into your application like Jaeger or Rollbar, all the way up to using a hosted service for this, something like Datadog or New Relic, that pulls that out and kind of manages that for you. Either way, you want to pick the right thing that fits your budget and the amount of resources you have to work on this, but most importantly, have some kind of monitoring in there as well. And that takes us right into step number 6. Now that we're monitoring things, we need to be alerting on things too. Because one of my pet peeves is finding out that there's a problem in production from my customers instead of finding out that there's a problem in production through an alert. So you want to have your monitors running, you want to set what the thresholds should be, and then you want to alert on those thresholds as well. So alerts can take multiple forms. You want to have like warning level alerts and error level alerts as well. So a warning is letting you know that there's a scenario that could get critical, and then a critical is whenever that threshold is reached. You want to monitor things like your memory, CPU utilization, your disk space, like we talked about in the monitors, but then also metrics that are specific to your application. For example, if you're running an API service, you want to be measuring the response time of your API endpoint calls and then alert when that exceeds a certain threshold. One final tip on alerting is you should avoid the scenario of unactionable alerts. And what I mean by this is whenever an alert comes out through your notification system, however that is set up, it needs to be something that someone has the responsibility of dropping everything and resolving that alerts. I've seen countless numbers of scenarios where you have alerts that you look at it and you're like, oh, that's really not an issue. We can deal with that later, or we need to adjust that alert because that's not really indicative of a problem. And so you start ignoring alerts. It leads to alert fatigue, and then somewhere in that stream of alerts is going to be a real one that you need to take action on, but you don't because it's lost in a stream of alerts that you've taught yourself to ignore. And then we're back into that scenario of finding out that production's down through our customers rather than finding out through our alerting and monitoring system. All right, last tip, number 7, you gotta have backups. And by backups, I'm specifically talking about backups of your data. So you're storing data in databases and storing files on file systems. You have to be backing all of that stuff up, but it's not enough to back it up. You've got to be able to restore that as well. So if you have backups turned on, but you've never actually restored that to make sure that it runs, you don't technically have backups. It's only through knowing that the data that you're storing in your backup is enough to bring the system back to life, and that you know how to get it out of the backup into a production state. So backups and testing your backups to know how to use them. All right, I hope those tips were helpful for you. I hope you got a little something to take away out of those. If you want to learn more about DevOps skills and how you can use DevOps practices to improve your skills as a software engineer and make maintaining, scaling, and growing your application better and easier, be sure and check out my channel, DevOps for Developers, on YouTube. Thanks, and I'll see you later.